All right, so this is lesson 5.5, day 3, and we are solving polynomial equations by factoring. So it's going to feel like a combination of the last two lessons, but we are this time doing polynomials that we're factoring, and then we're solving. So solving means to find the roots, or the zeros, which we know are where they're touching that x-axis at. So we are going to factor, which let's look at this example here. Factoring, this we can use the shortcut method here because we get -8, and the factors of -8 that add to get -2 are -4 plus 2. So we can go ahead and factor as x minus 4 and x plus 2 equal to 0, and then we can solve. So x minus 4 equals 0, x plus 2 equals 0. So minusing 2, we'd get x equals -2. Over here, adding 4, x equals 4 is our other 0. So what that would look like on the graph is -2 and 4, and it would be going through those two zeros. So recall that when you're solving by factoring, your equation needs to be set equal to 0. Why, you ask? Because we're trying to find what x equals when the polynomial crosses the x-axis, which is where y equals 0. So y is at 0 there, so we want to figure out where our x's are at. So here's our methods. We've seen all of these. Greatest common factor, difference of squares, sums, and difference of cubes is our newest from this chapter. Perfect square trinomials, general trinomials, and then grouping. So let's go ahead and take a look at some examples together. This next page. Oops. Maybe. All right, so for our first ones, don't forget to look for a GCF first. Always, always, always. So for this one, they all have a y squared in common. So when we pull that y squared out, we are left with y squared minus 7y minus 18 equaling 0. So now that it's just a quadratic in here, we can go ahead and take our first times last. Factors of -18 that add to get -7. Yeah, -9 plus 2. So we're going to shortcut with the -9 and the 2. And we're going to set that equal to 0. But don't forget up here that we also have our y squared that's equal to 0. So every single part gets set equal to 0, and then we solve. So square root of 0, well, that's just 0. So there's 1. Add 9, so y equals 9, the other. Minus 2, y equals -2. So there's our three answers, -2, 9, and 0. So you want to represent all of those, even putting that GCF equal to 0. So over here, again, GCF, I want you to try this one, and then pause. So pull out that GCF, then factor, it should be a shortcut, and then set every single part, including that GCF, equal to 0 to finish solving. So try this one on your own, and then check when you're ready. All right, so let's go ahead and check number 2. So pulling out a k cubed, then factoring the trinomial here using 8 and -4, and then setting every single part equal to 0. So we should have 0, -8, and 4 as our zeros. All right, let's take a look at the next one here. So again, make sure that it equals 0 first. That means subtracting this and getting it to the other side. So now, when we subtract it on both sides, it's minus 3x squared equals 0. So next step, there's no C, so that means start with GCF here. And now, we can just set both parts equal to 0. And solve. So here is 0. There's no plus or minus. Add 3 to both sides, and x equals 3. All right, so on the next one, we're going to use the U method of factoring. So we have where we can set our parentheses squared minus our b, and then to the first, and then plus our c. All right, so what would go in here would be x squared and x squared. So our u is going to be equal to x squared. So u squared minus 50, u plus 49 equals 0. So now we can go ahead and factor it. So the reason we're using u on this one is because there's no greatest common factor to pull out of there, and we can't just factor when it's to the fourth the way that we would quadratic. We've got to use that u method. So let's go ahead and factor this now that it's squared. So it's u. What are the factors of 49 that add to get negative 50? Well, that would be negative 49 and negative 1. And then we can now go ahead and put back our x squared, and then we can finish solving. So for this part, we've got x squared minus 49, which we can add 49 and then square root. So x equals plus or minus 7. Here we can add 1, then square root, so x equals plus or minus 1. And the next one is going to be a difference of cubes for this one, since we've got it cubed. So try that one on your own. And then I definitely want you to try number 6, which is just like number 4, using that u method. That will help keep your brain fresh with that. So try 5, then check, and then try 6, and then check as well. All right, so let's take a look at number 5 here. So it's 2x that's being cubed and 3 that's being cubed. So it should be a 2x minus cube, keep the same, then the opposite sign, then the always positive sign. So square the a to get 4x squared, square the b to get 9, and multiply the 2 in here to get 6x. Then we put the 2x minus 3 equal to 0. Remember, we're solving. Then we put the 4x squared plus 6 plus 9 plus 6x plus 9 equal to 0. So this one's easy. Add 3, divide by 2. Over here, though, we can't factor. There's no factors of 36 that add to get 6. So this one, if you can't factor easily, then you're going to need to use the quadratic formula. So this one did have an additional couple of steps there. So here's the quadratic formula worked out, and then it ends up becoming imaginary because it's a negative 108. So we pull that negative out to become an I, and then we take 108, find a perfect square, and then simplify, and then we look to all 3 numbers to see if we can simplify those. So please look through these steps of quadratic formula. If you didn't get that concept mastered from the last lesson, then definitely work through this. If you did, perfect. Go ahead and move on to number 6, which again is just like number 4. So please practice that one and then check your answer when you're ready.